If you are an SDET, this is a treasure for you. I have devoted so much of time and collected 10 Java questions that were asked in Flipkart interview for Java. And I'm going to explain you each one of them, also give you tips on how you can impress interviewers with a well structured answer. This video is free for you. I only need your attention by the end of this video, and I give you my words, you will be ahead of so many candidates after watching this video. So without wasting any time, let's begin. So in the screen you see the first question, which is saying that explain the Java memory management, and which says so basically interviewer will be expecting that you explain him the stack and heap memory of Java, and this is a very common interview questions. This has been asked multiple times in multiple interviews, and this has been asked in Flipkart as well, and this is the most important core Java concept as well. Don't worry, I'm going to explain you stack memory and heap memory in a very simple way. All right, so basically let me just select a marker, and when the interviewer asks you that you have to explain the memory management system in Java, it's a simple answer to this question. So the answer says that there are two types of memory in Java. The first type of memory is called as stack memory, and the second type of memory is called as heap memory. So the stack memory, we can have multiple stack memories like this. Remember this, we can have multiple stack memories like this, and the stack memory works on the LIFO principle. Alright, and the heap memory is only one. Okay, and it's a bigger memory, it's a bigger in size. Alright, first of all, what you need to say when interviewer will ask you that you have to explain the Java memory management system, you have to tell that the memory in Java is managed by JVM, which is the Java virtual machine. Alright, so JVM is the guy who is responsible in managing the memory for Java. And where is the memory actually? Where is the data getting stored? The data is getting stored in RAM. So everything, whatever data variables, whatever classes you define, everything is getting stored in RAM. And inside RAM, there are two types of memory. The first type of memory is called as stack memory, and the second type of memory is called as heap memory. Heap memory, always remember, it is a permanent memory. It is a permanent memory, and stack memory is always the temporary memory. Alright, so basically stack memory works on the LIFO principle. So example, one object will go inside, okay, and once the stack is full, once the scope of the object is finished, the object will start coming outside in LIFO manner. And sometimes you might have encountered an issue called as stack overflow. Okay, stack overflow. So that issue is always coming from overflow. So that issue is always coming from this particular memory. So in code, whenever you get a stack overflow memory exception, it means your stack memory is full and you need to change your thread, or you need to use a different stack. Always remember, this stack memory is thread based, so every thread has its own stack memory. So for example, this stack is for thread T1, this stack is for thread T2, and this stack is for thread T3. Alright, so every thread has its individual stack memory, but in heap memory it is not the case. In heap memory, if I have thread T1, T2 and T3, all the threads will share the same heap memory. Alright, and in heap memory we always store objects, and in stack memory we store references. Okay, references and variables. Alright, so if you just explain this much of it, then that's it, the interviewer is done. Alright, so what is the answer written? The answer says stack, it is a method level frames for primitive and object references auto clean on method exit LIFO. Right, So basically this is auto clean. Auto clean in the sense when your when your method scope is finished, it will be automatically pulled out. Alright. But who cleans the heap memory? Our GC will clean the heap memory, which is called as garbage collector. So in Java, there are garbage collector who will come and clean the memory. What are heap? Heap store the actual objects. Just now we have understood. It is divided into young generation and old generation. Alright. So if I explain you this part, you can also go little bit deep under heap memory. Alright. So if you see the architecture of heap memory looks like this. Okay. So this is our heap memory. This heap memory is divided into two sections. One section is called as young generation and other section is called as old generation. Okay. And even this young generation is divided into three parts. The first part is called as Eden. The second part is called as S0, which is a survivor 0, and the third part is called as survivor 1. And how does objects actually work? So basically the object work in a very simple way. Whenever you create any object, for example, I create a new object called as car. Object O1 is equal to new car. So whenever I do this, or car O1 equal to new car, alright. So whenever I create an object like this O1 is created in Eden space. Always remember, alright. And there is some reference who is referencing this object. Once the reference is clear, this O1 will move to S0 and with certain age, and then S1, and then after the garbage collector run, this O1 will finally move to old generation. So the garbage collector works on mark and sweep algorithm. Alright. Cool. So this was our first question. Alright. If you have any doubt, you can just write down in the comment section. I reply to every comment. Let's move ahead. So the second question is a very interesting question which says how does the hash map works internally. Okay. So you have to find out the working of an hash map internally. It's a very simple answer. So basically you all know that hash map work on two things, key and value, right? Key, value. So whenever you want to store anything inside a hash map, you need to have a key and you need to have a value. For example, car can have a key of 0, truck can have a key of 1, bus can have a key of 2. So what are all this? These are all our data. These all are data. So when you store this in a hash map, what happens? We have something called as hash functions. Hash function. So when you are storing your key and value, when you are storing your car and 0, this hash function will come and this hash function will convert the car variable into a hash. So basically there is an algorithm. Hash function is nothing but an algorithm to convert it into a random hash. A random hash look like this: 2, A, C, B, Z, 9, 7, X, Y, something like this. This is a random hash. But this car is now converted into this hash, and now this is stored into memory in something called as buckets. Alright. So if someone asks you how does a hash function work, so basically hash function work in a key value pair. The key is converted into a hash with the help of a hash function. Okay. And the data, this hash is stored in memory in buckets. And that's all. That is all you have to explain in short the working of an hash map. So what is the answer? It uses an array. It uses an array of buckets, each a linked list. or balanced tree. In Java 7 we had linked list. In Java 8 we have balanced tree. Okay. What is the key hashed? Modulo bucket size, and this bucket size will be your index, right? Collisions, alright, collisions added to linked list with equal checks, and tree enables log o log of n lookup. Alright, so these are the things that you need to explain. Okay, cool. Let's move ahead to the third question. This is one of my favorite questions. So whenever even if I am taking an interview, I ask this question sometimes because this is a little bit of tricky and little bit of logical. Okay, so I give you an example. So first, what is the question? The question is what is the difference between equal sign and dot equal sign, dot equals. So for example, I am having two string. So let's say a string s1 is equal to new string. Okay, and inside this I'm writing, let's say, Aakash. Okay, and I am creating one more string s2 is equal to new string, and inside this also the value I am giving is Aakash. Alright, cool. So now the question arises, the differences between double equals and dot equal sign. So I can either write s1 equal s2, or I can also write s1 dot equals s2. Now what do you think? This is my s1 and this is my s2. What do you think, which value will return true and which statement will return false? Just give it a thought. Alright, let me tell you. When I write s1 equal to s2, the very important thing which you need to remember is this statement will compare, value plus memory address okay, and this statement will compare only value. Alright, so what is the value of s1? The value of s1 is Aakash, correct? And what is the value of s2? The value of s2 is Aakash, right? So no doubt our second statement will return me a true. Why? Because it only compare the value. But when we talk about the first statement, which is s1 equal to s2, this will return me a false. Why they are not equal? Because it is now comparing the memory address as well. And why memory address is different, I will tell you. Since we have two different string, okay, so in the heap we are creating two different objects. Why? Because we are using new keyword. So when you are using new keyword, it will create two different objects, and that means this object has a different memory address and this object has a different memory address, and that is the reason this statement will return me a false value. So this was the question, and you need to answer that this compare references equality and dot equals compare logical equality, and it can be overridden. Okay, it is useful for comparing the values. Alright, cool. Let's move ahead on our fourth question. Okay, the fourth question says Java, explain me the finally and finalize keyword. This is the question which I was also asked when I was changing my job in my previous organization. Okay, so this is an interesting question and it's very simple. You don't need to worry about it. I'm just going to explain you in simple terms. So I have three keywords: final, finally, and finalize. Okay, first of all, don't get confused that these three keywords are related. Okay, very important thing, these three keywords are not related. Okay, this doesn't have any relationship. Cool. Now, what does the keyword final tells us and what does it do? It's a very simple thing. Final will tell me that overriding is not possible. Overriding not possible. Not possible. So basically you must have come across few statements like final int x is equal to 10. It means that whenever we define any variable as final or whenever we define any function as final, no one can override this variable. Now the value of this function is 10 and no one can change the value of x to 20, no one can change the value of x to 50, no one can change the value to 100, right? Now this is final. Similarly goes for function. If you define a function as final, no one can override it. So if you know that in inheritance we can override certain functions. So for example, if I have class A, okay, class A, and I have certain function probably, okay, and I have class B which extends A, okay, I have probably here void do something, void do something or do some, okay, I have certain implementation over here. I can have the same function do some over here, okay, and this function can be overridden, the implementation of this function can be overridden. But if I define this function as final over here, now no one can override this. This will throw me a compilation error. This is the meaning and this is the use of the final keyword. Now what does finally says? Finally is basically it is a block which always execute post try catch statement. So if you have written a try catch statement before, you must have know that you write something like this, try, okay, and you try something over here, and then you have catch, okay, and in catch statement what do? You catch an exception. So basically you try something, you tried 1 divided by 0, okay, you tried dividing 1 by 0, okay, if it is success then you will directly return it from here, okay, and if it is a failure will be an exception that will be thrown and it will be catched over here. Alright, but after try catch we write one more statement which is called as finally. So we write one more statement called as finally. And why do we write finally? We write finally because even if try throws an exception, this block will always execute. This block will always execute, okay. So whenever you see this thing called finally after try catch, it means that this block, no matter this is success or this is failure, this finally block will 100% it will work, it will execute. So if you write system.out.println hello world, that means hello world will be printed no matter your try is failing or success. And alright, and at the last finalize. Finalize, it's a very very rarely used term and now it has deprecated as well, so no one generally put pressure on this that what is finalize, but you just need to know that finalize is just an garbage collector hook which was used for object cleanup. Alright, so if you remember from our first question, I told you about garbage collector, so which is there in the heap. Alright, so it's just a statement for a garbage collector which will come and clean the objects in the heap memory, right? That's it, and that's it, you are done with your fourth question. Alright, cool. Let's move ahead with our fifth question. Okay, Now we have our fifth question on the screen, which says that we have to explain the different type of references. The first one is strong reference, the second one is software reference, and the other one is weak, and the fourth one is phantom references. Alright, so if you don't know, then there are four types of references, namely strong, soft, weak, and phantom. This can also be a interview question. They can ask you that what are the four types of references. You need to remember this term: strong, soft, weak, and phantom. Alright, let me just explain you in brief what does all of this mean. So for example, I have a heap memory over here, okay, and I write car C is equal to new car. Okay, so I have created an object C. It means inside my heap memory I have an object allocated, memory space allocated for this object C. Okay, cool. Now I have another stack memory. I have another stack memory over here, which is calling this object, okay, which is referencing this object basically, cool. Now you need to know that this stack memory works on frame. And this stack memory has LIFO principle. Okay, so there is a variable C which is referencing this object, car object. Alright, the variable C is referencing this car object. So for example, this variable C is inside a function called main. Now as soon as this main is out of scope, this frame basically, your C variable is here, okay. Now your program starts here and it reaches the closing bracket. So as soon as this we reach the closing bracket, this frame is finished, and if the frame is finished, this will be pulled out. Okay, this will be pulled out of the memory, and as soon as this is pulled out of the memory, this no longer exists. If this no longer exists, this connection is broken, and since this connection is broken, this reference is also broken. Alright, if the reference is broken, now you must have understood what will happen. Now this is a free object, no one is there to protect it. Now the garbage collector will come. Garbage collector will see that the object is free, I can clean it up, so it will clean it up. Now we will understand what is a strong reference. So when this object was actually referencing this thing, this was my strong reference. So when someone from the stack memory is referencing into heap memory, then that will be a strong reference. As soon as this thing is broken, now we can have either weak reference or soft reference. Okay, now what has happened? This is now broken. Strong reference is broken. So now there will be either weak or strong, weak or soft. Now what is the difference between weak and soft? That we need to understand. So basically the differences between weak and soft is that in case of soft reference, we tell the compiler, we tell the garbage collector that okay, you come, and if you find that this object is a soft reference, don't delete it directly. Okay, you can delete it, you are only allowed to delete it if you are running out of memory. So this heap memory is inside my RAM. If my RAM is running out of memory, if my RAM is full, then only garbage collector will come and delete this car object in case of soft reference. Okay, so it is not a compulsion to delete the object, but it will check the memory size. If the memory size is full, then only it will delete. If it is not full, then it will keep it. Okay, no problem, I will delete it later. But if this is a weak reference, no matter memory size is full or not full, it will definitely delete it. So that's the major difference between weak reference and soft reference. Alright. And the last one is phantom reference, which is used to track object lifecycle post finalization, and it is rarely used. Alright. Cool. So with this, we have also understood our fifth question, and I hope you don't have any doubt. If you have, you can feel free to comment down in the video. Right? Let's move ahead. Okay, this is our sixth question, which say that we need to explain transient and volatile. Okay, it's something which is related to concurrency. Okay, this both the keywords are related to concurrency in Java. Concurrency in Java. What does transient keyword do? And before explaining the transient and volatile keyword, let me tell you, this both the keyword doesn't have any relationship in between them. Transient does something different, volatile does something different. Okay, both of this don't have any relationship. Cool. Okay, so what does transient keyword do? It will tell the object that serialization is not needed for the field. Okay, and you need to skip this. So let me tell you, if you are a SDET, if you are an automation engineer as well, you must have come across the thing called serialization and deserialization. Okay, what is serialization and deserialization? It's basically offloading an object and onloading an object. So basically you have a class A. Okay, and you have certain data variables, int x, int y, int z probably, and you can serialize it, means you can load the value to this variables, and deserialize means you can offload the value of this variable. So whenever we use this transient keyword, we are telling the compiler that serialization is not needed for this variable, and you can feel free to skip this. Okay, so for example, I have a int x is x, okay, defined. If I use a keyword transient over here, it means I am telling the compiler that don't serialize this. Okay, skip this. Cool. The next is volatile, and it prevents the caching values by the thread, and it will, thread will immediately see the changes. So for example, I have a string car color is equal to, let's say, red. Okay, now I have two threads, thread T1 and thread T2. What thread T1 does, thread T1 comes and change the color of the car from red to probably violet. Okay, T1 changes the color of the car from red to violet, and T2 changes the color of the car from red to blue. Okay, now if I use a volatile keyword, it means that as soon as the T1 changes color of the car from red to violet, T2 can directly, without any lag, can access the color violet. And if I add the volatile keyword in T2 as well, okay, what it will say, that as soon as the color blue is updated by the variable T2, T1 will be able to access the new color T, which was changed by T2, which is to blue, right? So transient, which says the field not serialized when object serialized, and volatile, which ensures visibility across threads. Read write, go directly to the main memory and not thread local caches. So it's basically related to caching. Alright, so with this we have also learned the sixth question, and we are moving back again to seventh question. Okay, streams and lambdas. So this basically, these are new Java concepts. After Java 11, I guess they have introduced streams and lambdas. Okay. So first of all, I'm gonna explain you lambdas and then streams. So lambda, basically it's just a lambda function. So it's just a way of writing functions. So initially we used to write functions like this, probably void, and you can have something and then function name and then like this, right? And if you want to write a function inside a function, then you will have probably function x, and then inside it you will have y, okay, and then inside it if you want another function, then you will have z, right? So the system was getting complicated. To solve that problem, we have introduced lambda functions. So lambda is just a way of writing this. So x, something like this with the help of arrow function. Inside it you can write another function and just close it. So instead of writing this entire thing, you can write this in just one line. So lambda is just a way of writing, it's just a syntax. But now when we talk about streams, streams is basically used in arrays or in filtering or sorting the data. So for example, I have an array of probably 1, 2, 3, 4, 5. It is a very simple array. In real life you don't have this simple array, you will have a more complex case, and for that streams are required. So basically, if I ask you that you need to sort out, you need to filter out all the numbers which are even. So there is a typical method. Initially what we used to do, we used to write a for loop, and then we used to write something, and then inside the logic, inside this for loop you will write the logic that percentage 2 is equal to 0 or not, if then return true. It's a big thing. But now since we have streams, what we will do, we will simply convert this array into stream. So to convert this array into stream, we just write array dot streams, okay, and then we will collect the streams, and then we write dot filter, and inside this we will write our filter logic, and then dot collect. So finally what we have done, we have converted our array to streams, then we have filtered the data, and then we have collected the data. As simple as that. So this is how it works. So streams and lambdas help write concise functional code. Streams enable functional style operation, example filter map reduce, with better readability and parallelism. Alright, let's move ahead to our 8th question. So in this question, we have to explain the differences between abstract class and interface. It's very simple. So basically, what are abstract class and interface is used for? It is used to achieve abstraction. Okay. And what is abstraction? It is just a way of hiding the data. Okay. So before understanding the abstract class and interface, I'll just give you a short idea of what is abstraction. So basically, imagine you are driving a car. Over here, okay, and now you use the brake pedals, okay. Since how do you use a brake pedal? You just put your legs on the brake pedal and you just press it, and your car will stop, right? You don't know what is going inside it, what is the function that is written inside the brake pedal, that what will happen, which wiring will go, and which wire will hit which circuit, right? You don't know anything what is going inside. Even I don't know. So we just know that we need to hit the brake pedal and the car will stop, and that is called as abstraction. That means hiding the data and only showing the necessary things, and you can hide the implementation. So how brake pedal works, that implementation is hidden from the user. You just know the necessary part, which is pressing the brake pedal, right? In the Java code as well, you can do the same. You can just expose the function and you can hide the implementation of that function. So for example, you have this function called as void press break. Void press break. So here if you have seen that I have only defined the function, I have used a semicolon, and whoever class who is going to implement this, for example this is inside my class A, okay, and if I have a class B which implements A, now it is the responsibility of class A that you need to implement press break. You need to implement press break, okay, and you need to give the implementation over here. So this is how data abstraction work. Now this can be done in two ways, one with the help of abstract class and one with the help of interface. So when you say that you need to have abstract class means you have a class A which is an abstract class, and inside abstract class you can have only abstract method. It means all the methods should be abstracted, and someone has to implement it, okay, but here is the catch. I can have one more function which is not abstract. So for example I had one function void press break which was an abstract function. I can have one more function void press accelerator, and that cannot be an abstract. You can give the implementation of this function over here, and you can just don't give the implementation over here. So 0 to 100% of abstraction is achievable in case of abstract classes, and in case of interface only 100% abstraction is achievable. It means when you define an interface, no function inside the interface can have their own implementation, okay. In abstract class, what do we had? This was my abstract class. In abstract class I can have two types of function, one function whose implementation is not present, another function whose implementation is present. But in interface I can have only those type of function whose implementation is not present, and the implementation should be done by a class who is extending this interface, right? So abstract class can have state, field, partial method and implementation, and interface only static method unused for multiple inheritance. So this solves the diamond problem as well. This will solve your diamond problem as well, okay. Let's move ahead to our ninth question. So this question says that you need to explain the string constant pool. It means Java stores the literal string in a special cache in heap, allowing reuse, avoid duplicate object. So it's just a simple concept which I have just explained you the few minutes before, that I have a heap memory, and inside this heap memory I have my string pool stored, right? So whenever we write string s1 which is equal to new string, right, it means it creates a new block of memory, and this block of memory is called as string constant pool, okay, and it helped me to reuse the memory. So this is my s1, someone s2 can also refer to this memory, s3 can also refer to this memory, s4 can also refer to this memory. This is the use case of having a string constant pool. So it avoids duplicate objects, okay, and string dot intern can use to manually intern a string. Cool. Let's move ahead to our last question of this video, and which says how to try catch finally block execute when return is used. All right, So this question we have just learned few minutes before. Whenever we use a return statement, finally will always execute no matter what, right? So you write something like this: try, then you have a catch block, okay, and then you have a finally block. So what happens? Example, you are trying to divide 1 by 0, okay. If you are trying to divide 1 by 0 and if this division is successful, you return true. If this division is not successful, you throw an exception E over here, and at the end you print a statement system.out.println that hello. Okay, now what will happen? There can be two possibility. Either this statement is success or this statement is a failure. If this statement is success, it will return true, and as soon as it returns true, it will not go inside the catch block. If try returns true. If try returns false, it will go inside the catch block. Okay. But irrespective of the case that try returns true or try returns false, it will always go to the finally block, and it will always print a hello in my console. So this is what the question is asking. The question is asking that how do try catch finally block execute when return is used. So when return is used, finally will always execute. Okay, so finally executes even if return is within the try or catch, and it is useful for cleanup. Finally block always run before the method runs. And that's it. We have reached the end of this video. I hope you have learned something. If yes, you can just consider a like or a subscribe. It just motivates me. And that's it. We will come back with another video, with another session. I teach Java and I teach Selenium. So feel free to subscribe to this channel. Until then, goodbye. Bye bye. Take care.